Hello everyone. In this session, we want to discuss Network Access Protection, NAP. In previous sessions, we talked about configuring the network policy server as a dial-up and VPN access server, as a wired and wireless server. We have a third option, configuring the NPS as a NAP server, Network Access Protection. Network Access Protection is a technology that allows you to restrict network access based on the client's health. So you have your client computer here, and the client computer wants to access your network remotely. You have radio set up, you have a remote access server set up, you have an MPS server set up. If you configure the MPS as a network access protection, then that network access protection is going to have some rules in place that will dictate whether or not the client can access the network based on the client configuration itself. For example, the client computer will have a component called the System Health Agent. And the System Health Agent is the component that will evaluate the computer to see if that computer is configured with all the settings that it needs to be configured with in order to have access to the network. The System Health Agent, after it has scrutinized the computer, will create what is called a statement of health. And this statement of health would have the health configuration of that client computer. Let us compare it to a government agent that is sent out by the Government Standard Institute in Barbados to go out to different supermarkets to check on items to see if those items have dates on them that have gone, that are no longer valid, and then those items should not be on the shelf. If an agent goes out and does that manually, then the agent has to write up a report and take that report back to headquarters. Well, you could look at it the same way here. The System Health Agent evaluates the computer. Whatever the computer has on or does not have, it makes a statement of health. That statement of health is sent then to the server itself. The server has a component called the System Health Validator. We call them SHVs. And the System Health Validator is going to compare that statement of health with the policies that you, the administrator, created, the health policies. Your health policies might have regulations such as there must be an antivirus program installed on the computer. The computer should have certain updates. So you get to say what the policies are. Now, if that statement of health that is sent to the system validator, when it is compared then to the policies that have been set up on the computer, which is the MPS server, and they don't match, then the client computer will not be allowed access to the network. We want to take a look at configuring network access protection. And first we have to access the NPS server. So we click on Network Policy Server, and we're going to configure as a network access protection. Let's just look at what we did before. We had looked at radio server for dial-up or VPN. And we also, in a previous session, looked at radio server for 802.1x wireless or wired. In our session today, we're looking at network access protection. And let's look at the description here. When you configure MPS as a NAP health policy server, what you're doing is creating health policies that allow MPS to validate the configuration of the NAP capable client. This would be the client computers before they connect to your network. So before the computer connects to the network, they have to be validated by the MPS server, which you are now configuring as a network access protection server. If there are clients that are not compliant with the health policies that were set out, then these client computers can be placed on a restricted network and automatically updated to bring them into compliance. So if a computer wants access to the corporate network and that computer has no updates, has no antivirus, that computer can actually be put in what we call a remedial network, where there is an update server that will actually force those updates on the computer before that computer is accepted within that network, before that computer is allowed to connect to that network. Let's go ahead and click on Configure Network Access Protection. Now, we can configure network access protection as wireless, wired, virtual private network, DHCP. The ones that we want to look at in this session is configuring the network access protection server as a dynamic host configuration, protocol enforcement method, and also as a virtual private network enforcement method. For the first one, DHCP, and we call that DHCP enforcement. If we have a computer and the computer wants to receive unlimited IP4 network access, it means that we're going to use the computer address to restrict that computer from access to the network, but we're doing it using the IP address. The computer has to be compliant with all of the policies that were set out. So what DHCP enforcement does, it verifies that a computer is compliant before granting that computer unlimited access to the network. If it happens that the computer is non-compliant, the computer will receive an IP address that has limited network access. In other words, the computer will not be allowed to access the network, to access probably the folders or the files, but the computer will be allowed in, but will not have access to any of the resources. You can look at it like this. If someone came into your international airport, they bought a ticket, they arrived at the airport, but before they enter your country, they have to go through customs. If customs look at their documents, and customs sees that the documents do not conform to the regulations, then customs will send them to a room or a place where they will then look again at the documents they have and decide whether or not they can come into the country. So you could compare compare that to a remediation rule. The only difference here is what we can do when we do the NAP configuration using DHCP. We can force the computer to become compliant by putting those policies on the computer, whether it is that it's some updates or antivirus, we can actually force those on the computer. So DHCP enforcement again will verify that the computer is compliant before granting that computer unlimited access. One advantage of using DHCP as a method of enforcement is that you can set up what we call user classes so that specific machines, for example, those machines that are non-compliant DHCP systems, you can give them specific rules or limited access to the network based on their addresses. So when a client computer attempts to receive an IP address from DHCP, the DHCP enforcement will check that health policy to make sure that that computer meets the compliance. We're going to go ahead and choose dynamic host configuration, DHCP, as the method of enforcement. Now here, you can change the name or you can leave the default name. The default name that you would get is NAP DHCP. We're going to go ahead and click Next to continue. And at this point, we need to add the remote DHCP server that we're going to use as the Radius client. We want to click on Add. And remember, if you have an existing template, you can use it. And we don't have a template, so we actually have to create the friendly name and choose the server. So for our friendly name, we're going to type DHCP enforcement. We're going to call it DHCP enforcement because we're using this method to restrict users. This is just a friendly name, so you can give it the name that you want on your network. Now we have to put the name of the server that we're using, the Radius client server, and we're going to use server 2. So we're going to type the fully qualified name. And we have to type a shared secret unless we had done a template, and we didn't do a template for the shared secret. So we're going to have to come down here and type the password, which is the shared secret. We're going to type password 01. And we're going to come down. We're going to type password 01 as the password. So we want to click in the shared secret box and Shift P for capital P, ASS WORD 01. We want to click in the confirm shared secret box and repeat that password, ASS WORD 01. Next, we want to click on OK to continue. So we have the Radius client. The method that we're using is DHCP Enforcement, and we also gave it that friendly name. And we want to go ahead and click Next. And at this point, we want to specify a DHCP scope. If we don't specify a scope, then the policy is going to apply all NAP-enabled scopes that are set up in DHCP as the selected DHCP servers. And one thing I need you to remember here, if you specify a scope within DHCP that is not NAP enabled, then you have to enable NAP for the scope after completing that wizard. We want to go ahead and click Next, because we're not going to specify any particular scope. Any scope that the DHCP has, we're going to use those scopes. We want to click on Next. And here, we have the option to grant or deny access to groups of computers. So you would have already created a group and you have those machines in that group. If you don't select a group, then this policy is going to apply to all users. So we're going to leave the policy so that it applies to all users. We want to click Next. And here we're configuring the remediation server group. Remember we talked about that remediation room, that room where when the traveler comes to the airport and goes through customs and does not have the correct documentation, that person gets set aside where they have to go to interrogation room. Well, that's what we're talking about here. In our scenario, we have what is called remediation servers. So we will have a number of servers in the network, and they usually are WSUS servers that you configure your updates with. So you might have a group of them. So that's why we have to do a group, because you create a group and then you put the servers in that group. So we see we have an option here to select a remediation server group that you have already configured. So if you don't have one, you have a group, you create a group. So we're actually going to create a group. I'm going to click on New Group. And I am going to call that group Remediation Group. I'm going to use my keyboard. I'm going to click in Group Name. Make sure I click in the Group Name box. I'm going to type Remediation. Space Group. So that's my group name. And I want to click on Add. And I'm going to type the name of a server. I'm going to add a server. Type the friendly name. For my friendly name, I'm going to use Remediation Server. And I want to type the IP or DNS name of that server. And I'm going to type server 2. .contoso.com. I want to go ahead and click OK. So we have the remediation group name and we have the remediation server. I want to go ahead and click on OK. At this point now, you see we have in our second option, troubleshooting URL. So if you have a web page that provides users with instructions on how to bring computers and devices into compliance with your health policy, then you will type that URL here. So it means that if a user is trying to access the network, your corporate network, they send a connection request policy, and that policy is denied, what is going to come up will be the web page explaining why and showing you the link to click on to tell you what to do. So if you have a page like that, you will put the page right here where it says http:// you would put the web page. If you don't have a help web page, then do not type a URL. So let's just go ahead and click on next. And here we come to the Windows Security Health Validator. We do have a Windows Security Health Validator that is a default health validator. It's there by default, and this health validator has in it certain updates that you need to have in your policy, saying that if the client tries to access a network, these things should be on the client. Now we're going to come back a little later and look to see how we can configure that security health validator. Now, if you see here by default, we have enable auto remediation of client computers. So that's there by default. You will have to take it out. So if selected, if this is selected, any client computer that is NAP capable, if they are denied full access to the network because they are not compliant with the health policies that you have set out, they will be sent to the remediation group, to the remediation servers, and those servers, if you have them configured that way, will actually force compliance. If you don't select it, then the non-compliant client computers are not automatically updated and they will not be able to access your network unless you manually update them. So you have two options here on the network access restrictions for NAP ineligible client computers. So if the computers are not able to be configured as NAP client computers, maybe it might not be a Windows client computer, maybe it might be a down level client computer. What are you going to do? You will have to decide. Are you going to deny that computer full network access? Or are you going to allow them full network access? You would have to make that decision as an administrator. The default here is to deny full access to computers who are not eligible for NAP configuration. It would mean that they will have access to the network, but only to a restricted area. It will mean they wouldn't have access to any resources. It's like you can enter Barbados, but you can only stay at the airport. You're not able to go anywhere else. You want to click on next to continue. At this point, all you need to do is to look at what you have configured. Make sure that you have configured the things that you want to configure. And we had looked for our example here at DHCP Enforcement. There were other types, but we chose DHCP. And our help policies were that the computers would be NAP DHCP compliant and non-compliant. Our connection request policy was NAP DHCP. And then we click on finish. This is the end of our session on NAP DHCP enforcement. In our next session, we want to take a look at NAP VPN enforcement. And we also want to take a look at the system health validator. I want to thank you for listening.